Good morning to everyone. I'm sorry for my English because I'm Italian. I'm here just to show what I did in Italy in 5 years. So, just a little bit introduction. I'm Italian and I live in South Italy. Everyone of you knows that Italy has a boot shape and I live just in the hill. The name of my region is called Puglia. It's a little California because the weather and the environment is more or less the same. So now I want just to introduce myself about my formal education. I have a degree in electronics and telecommunications, and for you it's strange because I'm plenty far for farrier, but it's not true. My first job it was a technician for mobile phone. I was specialized to fix the Motorola mobile phone. And my job in the lab it was to control the quality about the alarm system because my lab produced this alarm system. But when I was working in that lab, I wasn't happy because my real passion and my skill education is farrier. Farrier, why? Because I'm very lucky because I had in my life the best educator for me. The first one is my parental grandfather. Is Michael. It's wonderful for me when I was kids to move in his shop and to feel the smell of the farrier shop. And I was lucky because as kids, as assistant, my grandfather to shoe horses is amazing. So my other educators, my father Oronzo, is still alive. It's amazing because he's old school, but he's a very open mind. He taught me a lot. So how do you understand? I'm a third generation farrier in my family. But I have also my brother, he's older than me, and he's a farrier too. He's one of my teachers. So I'm not competitor in my area. My competitors are just my family. So I have also a farrier education. I have a diploma from the military farrier school. This military farrier school is open for civilian, and they, after the selection, they take 10 civilian a year for this school. This school is very, very famous because every time we made shoes, it was made with the striker. This is an exhibition of my school. And the man that have the hammer is my master. This is a very old tradition. This is my farrier education. Okay. Everyone knows that the farrier is strictly connected to the environment. If you have seen something, some publication or some lecture from Brian Hampson from Australia, they explain that the environment is very important. So I live on that red point. The name of my town is Turi, and the red line indicates my main business area. I cover all my region, but my bigger business area is just this right line. And I live just on the edge of two kinds of environments. The first one, the green one, is a flat land. It's very famous for orchard, vegetables, and garden. My town is very famous for the cherries. It is brown area. There are a little bit hills, and is a place for plantation, hot and wet. So I want to pay more attention about the brown area. This brown area is called Murgia. It's called Murgia because the name comes from this kind of stones. because this stones comes from the ground. It's a very sharp-edged. And we are two kind of more just environment. This one is just rocks with some bushes. And we have also the more just in the forest. In the forest, the stones are a little bit smooth. And everyone knows that every environment develops a selective breeding. In the Morgia, there is indigenous horses. It's called Morgese. I think that you say you haven't this kind of horse. It's completely black. And the horse lives in the asper ground. It's fantastic because this kind of horses has a movement like Spanish horses because they have to walk in the stones. So they, whenever to walk or run, they have to keep the limbs very high. So now I want just to explain a little bit about my horses. Morgese horse's characteristics is completely black. You can see it has a plenty nice conformation. Mainly the front limb is a standard conformation. It's characteristic that the hind limbs, the hoof capsule is a little bit upright, and you can see the massive neck. The coat of this horse have to be in two colors, or total black or blue roan. But it's very important that when the blue roan had to be completely black, and the edge of with the head and the neck have to be blue roan. This is the two coats of this breed. Another characteristic of this horse is the head, because the head have to be convex. Every other shape of the head is not admitted. Of course, we are farrier. We are more interested about the hoofs. You can see the hoofs. It seems a little bit rounded, but for me, I call this kind of shape triangular because if you see the coronary band is not exactly rounded. Mainly in the medial area is a little bit straight than lateral area. That's something about my area, about me, and where the horses I'm showing. But I'm very involved in sport horses. In my area is a small area. It is a concentration of jumping horses, dressage horses, trotting horses, western horses. And we have to be able to show all these kind of horses. My big business is jumping horses, dressage horse. So, about sport horses, everyone knows that horses compete a wide range of equestrian sports that test various aspects of their athletic abilities, and they are, like sportsmen, horses are predisposed to injuries and lameness. So everyone of you know that equine front limb undergoes extreme tension during locomotion, mainly during the stance phase of a gait. We have a dressage during a competition. You can see the expansion, extension of the fetlock. For me, dressage competition or dressage horse has the main deleterious injuries than jumping horses. The other one is jumping horses. Is landing from the jumping. You can see that the right limb is touching the ground. In this case, there is a braking action, and the trailing is ready to support higher stress on the forelimb. We have the thoroughbred resources, and it's common to see that the fetlock is completely touching the ground. And you can see also that the deleterious stress that the forelimb is supporting, because there is a convex hyperextension of the carpus of the horses. But this extreme tension that is acting on the forelimb, it doesn't happen only in a competition, but this is a picture of a reading school. you can see just horses moving in cycle. You can see the hyperextension of the fetlock. So, in conclusion, farrier injuries are one of the main and most important problems that affect athletic horses. So, athletic horses is a big business. So, the horses industry, research, and promoting new methods to improve the horse's performance level. And to satisfy the improvement of performance level, the horses have to train a lot, and the exceed of training, they predispose the horse to trauma because they exceed the horse's physical capacity. So when the horses is exceeding their physical capacity, they develop a trauma. Now I'll show you some common trauma. This is a trauma of the flexor apparatus. It's common, and as a farrier, we more or less we have to work always with this problem because it's the main problem, and this problem can jeopardize the horse sporting career. And if the injury is severe, they compromise the horse sporting career. So you can see a picture, X-ray picture, is a multiple fracture of the horses, and in this case it is obvious that there is a premature end of the sporting career. This bad injuries comes from a famous American horse race horses, Barbaro, and everyone of you knows that this bad injury for the horses compromised his career. After a few months, he died. So now this is our field. Because to be a farrier today is very difficult because we have to pay attention a lot of stuff, like the new generation of horses, because we have horses with big muscles, with thin legs or hooves, or is it the opposite? So the farrier has a very difficult job because we have to manage and prevent injuries. This is our goal in our daily life. But it's not enough, because we have to help a performed horse better, because the rider wants to win competition, and so the horse will compete as well as possible. And this is the sport's priority. So at the end, to be a farrier is very difficult, because our goal is to manage to prevent injuries. But many times when we want to help horses to perform better, we predispose horses to injuries, and it is not a good deal. But everything moves around the sponsor. So to be farrier today is very difficult. And today the farrier have to be a very nice, good age, because the knowledge that we have is based on empirical knowledge. But it comes from the generation of expert eyes, because every one of you knows that the best master farrier in the world, they never write something on the paper. They just transmit their knowledge to the student. For example, I'm a third generation of farrier, and I know that I miss a lot of stuff, knowledge from my grandfather. My father is still alive, and I'm losing a lot of knowledge, because all life is not enough to learn what my grandfather and my father learned in his life. For example, my father is able to made horse nail shoes. It's fantastic because it's very close to the factory horse nails. But to be honest, I have not plenty time to spend some 3 hours with him to understand how it's possible to do it. But today we are a little bit lucky, because we are surrounded by the new technology that we can help us to understand mainly the horse locomotion, because the horse locomotion is our goal every day when we shoe horses. This is one of the simple approach about the study of horse locomotion. It's called horse inside out. It's very nice, because you can paint the bones, the muscle, the ligaments, whatever you want on the horse. And after that, you move the horse. For example, you can see the same horses is jumping the fence. It's amazing because you just with the drawing, you can see the orientation of the bones of the neck, the back, the orientation of the muscles, and this is a very nice education. Because if you want to shoe horses for a better performance, it's very important that you understand what is happening inside the horse body. This is the simple one. This is the last one. This is a horse with a rider. Oops. This is the horse with the rider. You can see a lot of body marker on the horse and on the rider. But to do this kind of study, we have to work with an university because you need a particular laboratory and special cameras, high-speed cameras. So this new approach is called biomechanics. We think that is the last generation of analysis, but it's not true, because the first one that invented biomechanical analysis, or better, the slow motion, is Edward Muybridge in 1878. He invented the slow motion just using 16 cameras disposed online, and when horses was running, they strike a small rope that actually the shooting of the camera. And the first time that Muybridge in 1878 that it showed the horses galloping. So what I'm doing now is something that already exists in the past. So this kind of biomechanical analysis explains the segments of the head, the bones, the back, and the limbs. Just the segments. With this kind of analysis, you can understand if there is a better extension of the forelimb or other parts of the horses, because mainly in dressage horse, the movements takes a lot of points and can win the competition. But as a farrier, we are just interested because we influence the forelimb from the carpus to the horse foot. So this is the area that we are interested because, as I said before, this area has a higher risk about injuries or lameness. But distal forelimb is a complex of ligaments, tendons, and bones. We have a deep distal flexor tendon, superficial distal flexor tendon, accessory ligaments of deep distal flexor tendon, suspensory ligaments, fetlock joint, extensor branches ligaments of capsule, of cartilage of capsule, etc. This is just a small part of the inner structure of the forelimb, but it's not enough to know exactly the name, because today is very important to understand their dynamic interaction and behavior. So it's very important when it's applied the load on the forelimb to understand how all these structures interact together. Because with our job, we influence these structures. Now you are seeing something about my machine, but it's not enough, just a small demonstration. So, before to build my machine, I traveled the world, I learned English, and started to study some public scientific paper, because I want to understand the interaction of all the structure inside the forelimb during stance phase of a gait. But something surprised me, because scientific paper like this, joint movements in the forelimbs and jumping also during landing, they say that relatively little is known about the actual loading of tendon injuries, the tendon during demanding activities. And they say that direct measurements of tendon forces is limited by the invasive character of these measurements. So this scientific paper summarized, they say that it's impossible to understand all the interaction of the distal forelimb. Another one, relationship between muscles, forces, joint loading, and utilization of elastic strain energy in equine locomotion. They say that invasive experiments are limited for both ethical and practical reasons. When they talk about invasive experiments, this means that the scientists make a microsurgery of the tendon or the muscles. They introduce small microchips, and after that, they with this microchip they connect with computer. After that, they test the horses or jumping or running, whatever you want. But it's limited because they cannot make a lot of implantation, because a lot of implantation means more pain for the horses, and they change the gaits. So, attaching strain gauges to the tendons of a live animal is likely to affect its gait pattern, and no study to date has instrumented all the important tendons simultaneously to record that data across a wide range of gait aspects. Is a big limitation, but they say that indirect methods such as musculoskeletal modeling are potentially more powerful than invasive experiments, provided the modeling results can be appropriately validated. So the last one paper that I want to show you, they say that dynamic simulation using musculoskeletal models can provide valuable insights into the mechanical factors that cause tendons and ligaments injuries. So you did the best part, because and I never find someone that can reply my questions. So I've tried to build something that can help to give me this response. So everyone knows we are Farriers. Farriers means to be very ingenious, because daily we try to adapt our tools to show horses we can invent, or we can try to understand with our empirical knowledge what can improve about our job, or improve something for the horses and their hooves. So my contribution as a farrier, I designed and developed and created a special device that is able to very accurately reproduce the equine forelimbs musculoskeletal structure with its functional and physiological position and the body weight during the stance phase of gait. The stance of gait are walk, trotter, canter, gallop, and landing from jumping, and then associate the study of biometrics and the dynamic biomechanics. The meaning of biometrics is just human measurements for live structures. So, next step is to reproduce the musculoskeletal model. It's important to reproduce the whole forelimb, because the forelimb is a complex about muscles, tendons, and ligaments. And the muscles and tendon structures cannot separate them, because it's very important for locomotion. Indeed, if you have seen some presentation from Christopher Pollitt, Jean-Marie Denois, or Mike Saboldi, you can see that when they apply the load on the forelimb, they try to anchor the toe of the capsule, because just applying the load, the forelimb slips away. It's because they haven't the muscle connected with the tendons. And when the muscle is not connected with tendons, this means that the musculoskeletal model is not closer to the reality. So, the anatomic parts from the carpus, dorsal foot, are taken immediately from the post-mortem of the horses. So this part is real. And the upper part, anatomic parts, like radius, superficial flexor muscle, axial ligaments of superficial digital flexor tendon, and deep digital flexor muscles are reproduced in an artificial way, because in my area it's very difficult to achieve the whole forelimb. This is my model. This part is real. The upper part is artificial. This cap reproduces the carpus, this pipe is the radius, and this clamp are connected with the artificial muscles. And it's not enough, because I want that my machine to be dynamic. So I'm applying the body weight. You can see that I'm applying the load on an axial way, and the foot is completely free and the product block is still there. I'm applying the body weight around 1 ton. It's a huge weight, but you can see the following is slipped away. But to do this part of the machine is very easy for me, but I was still unhappy because collecting the information on live horses and reading the scientific paper, they say that during the distance phase, they are the greatest forces acting on the forelimb, focused from carpus to hoof capsule. So I need other ears to adapt that machine for this purpose, to produce a stance phase or gait. Today, here in the United States of America, I'm introducing my machine. I call my machine Cellaro Dynamic Forelimb. Cellaro Dynamic Forelimb is a dynamic stance phase forelimb motion device. So you can see my machine that is working. You can see the stance phase of the gait of my machine. I produce them from the full contact to the breakover. And this is the first machine in the world is able to do this. You can see also during distance phase, the dorsal foot is completely free on the podder block. So we go on because I told you that I can apply the equine body weight on that machine. The equine body weight that the forelimb supports during different stances of gait, are different because we have a horse body weight sample, for example, 500 kilograms. And when the horse is walking, the forelimb is touching the ground, there is around 30% of his body weight is more or less 150 kilograms acting on the forelimb. During the trot, 3 meters per second, is acting 120% of body weight, is around 600 kilograms. During canter, 5 meters per second, is acting 150% of the body weight, is around 750 kilograms. And during gallops, 14 meters per second, is acting around 70. Body weight is around 850 kilograms. Jumping on train limb is acting around 200% of body weight, is 1 ton. Talking with Renata Weller, they say that the new generation of race horses, they can develop around 250% on the forelimbs touching the ground. So all of this horse body weight, I'm not invented. It comes from these main scientific papers. Because to do my machine, I'm always in contact with what is written in the scientific world. Because I want that my machine to be real as possible. So every scientific study is very important because we have to develop a protocol. The protocol is very important during the scientific study. And the stance phase of gait is divided in 6 steps. The first step is a full contact. The second one is 1/2 mid-stance. The third one is mid-stance. We have a 3/4 breakover, 1/2 breakover, and we have a breakover. The breakover, it means when heels is leaving the ground. And now if it is clear on the screen, here the heels is not touching the ground. And you can see also in this picture, also in this position when this breakover, the forelimbs doesn't slip away. It's very important to have these 6 steps of position because this is 6 steps will be the same for a walk, trot, canter, gallop, length from jumping because only in this way I can have the opportunity to standardize the protocol, and it's very important to be repeatable. For standardize, for scientific purpose, it's very important to standardize the machine to be repeatable without influence. For example, when you use live horses, there are a lot of influence. The first influence is the rider, the other influence is the weather, the other influence is the ground. So it's very difficult to standardize and to make repeatable the same experiments. In my machine, it doesn't happen. So now we can see how my machine can be useful. CDF helps to understand the interaction of the forelimb in structures that are invisible to the human eye. This is the goal, because we can see the forelimb, but we cannot achieve a lot of information. Now I'll explain what we can see with the machine. How you see, during these 7 stance phase steps, I take the X-ray picture, one from lateral medial, the other one in dorsopalmar view. So in these slides, there's a description, there's an explanation of the horse body weight. The body weight of the horses was 400 kilograms. We are analyzing just the landing, the gait is the landing of jumping. This is the kind of the X-ray is a lateral medial projection. Now the step that I'm analyzing is the full contact. So I can control the horse body weight is acting during the forelimb because it changed during the stance phase. Also, I have measurements of the deep digital flexor tendon and superficial digital flexor tendon. Here there are some abbreviation of the anatomical parts of capsule. And here we have some of the 22 parameters. The software that I use to make these measurements is Metron, is an American software. Now you can see what is invisible to human eyes. So now you can see the forelimb in motion. I don't know why. Sorry, it doesn't work. Okay, is it working? I think that for you is the first one you have seen the inner part of the stance space of gait. Because as I said before, our knowledge about locomotion, mainly what the movements of the bones or of capsule during stance phase, comes from empirical knowledge. This is what you see in lateral medial view, and this is what happens in dorsopalmar view. So, what? This one is a landing of jumping.
Okay, thank you.
Okay, the goal of why I built this machine, because I want that understand if what is written on the vet books is right or not, because every vet book is just a repetition from other books just to verify what they say. And the other goal is to try to develop a visual education, because as a farrier, I'm a practical man, and many times it's very difficult to read a scientific paper and understand their meanings. So, and I want to simplify the explanation of the scientific papers, trying to use this visual approach. So, and another, now I'm testing to develop this visual education. So we can have the lateral medial view, the dorsopalmar view, and the gait is the stance phase is the same. It's always the landing of jumping, and you can see correspondence from the first point of rotation. With this line, this is a correspondence with second point of rotation, and the third point of rotation. So this is the same the projection are different, is lateral, medial, and dorsopalmar, but the position is the same. Because, as I said before, when you standardize the steps of stance phase, it's easier to achieve information. Now, I want to offer you a two-dimension approach about learning. So you can see the same stance phase. You can see the video of the lateral motion, lateral medial motion, and you can see on the right the video of dorsopalmar motion. So, discussion. The purpose of this scientific study project is to reproduce a close replication of musculoskeletal equine forelimb to understand and describe the forelimb's internal structures and hoof capsule deformation under different circumstances of loading a stance phase of gait. So, this machine has inductive utility. This means that CDF is the only accurate, standardized, and repeatable method developed for analyze the real trimming or shoes effect during a stance phase of gait, associated with the interaction and response of the equine distal forelimb internal structures and tissues during locomotion. In this way, we can improve and develop technical shoes or material that prevent and treat lameness or maximize the horse's performance. And the best part is untouchable product process validation, because this machine is very close to the reality. Renata Weller confirmed this. And when you have a standardized, repeatable method, the process is untouchable. It's very useful with the knowledge that you can achieve from a machine. You can test on live horses. This is the step before to achieve information or to try to make the adaptation of trimming or shoe before the horses. So I'm at the end. The conclusion of my work is simple because it works. And now I want to spend a few seconds about source funding. It's very important when you make a scientific research to achieve money, because before to achieve this research, it's wonderful for me. I spend a lot of time, a lot of money, I make a lot of mistakes. So I'm so happy to say that the development of Cellaro dynamic forelimb is fully funded by myself. No one helped me with the money. So I'm Farrier, I'm trusting what I'm doing, and I hope that what I'm doing is useful for you. That's it. Thank you.